This is a low poly environment. As you can see, only outlines are being drawn here. It is clearly not cel shaded, as you can see a color gradient under the light. Now it is cel shaded with our surface shader with hatch shaded rocks. The gradient of color under the light has disappeared, with bands of color taking its place. Additionally, the tree leaves have also become bands of color. All shaders in this demo interact with multiple lights and change accordingly. We created these shaders by wrapping around the default lighting shader and extracting the output brightness. This is what allows it to handle multiple lights and shadows easily.
The first shader that we decided to make was cel shading, which is essentially taking a 3D surface and trying to emulate a 2D flat surface. The basic idea is we manually calculate our lighting using the Blin-Fong shading model and apply filters to it in order to create a cartoon shading. Specifically, we use a step function to divide the lighting into discrete bands. Using this method, we are able to create a shader, which creates a scene with limited tones. As you can see from the renders, this creates a nice cel-shaded effect, which is complemented by our outlines handled in the post-processing stack.
So painterly shading is a way to render images so that it looks like it was painted over by some artist with a paintbrush. And the way we implemented it is by using an edge detection shader, which first detects edges by calculating the gradients of the luminance at each fragment using a vertex fragment shader. Then we convert these edges into distances, so we know the distance to the closest edge for every fragment that we have. And you can see that down here. And then finally, we use those distances to basically layer on a quad or a grid of quads of paintbrush textures that we also combine with the color buffer of the original image.